In labor economics, there are three major participants: workers, firms, and government. Workers are needed, obviously. If there are no workers, there is no labor. Workers maximize their well-being. That is, they select the best option from available choices. In other words, they maximize their utility given some constraint on their time. Workers apply more time and effort for higher payoffs, higher wages, causing upward sloping labor supply curve. Firms decide who to hire and fire. Firms maximize profits. The price of labor and number of workers a firm is willing to hire generates the labor demand curve. Government can intervene in these agreements by imposing taxes on either firm or the worker, or both. Set safety and environmental regulations, set minimum wages, mediate labor union disputes with firms, require firms to shuttle workers from home to work, mandate firms provide birth control to female workers at no cost, ban the distribution of raw milk. Why study labor economics? Well, for one, to answer the three questions on the previous slide, and ask interesting questions like the one below. Why is there a shortage of math teachers? In the first or the second year, in my second year at A&T, I went to a meeting at the School of Education, which was trying to get a $3 million grant from the NIH to mentor middle school teachers into being better math teachers. Now, it came out during that meeting that apparently, according to them, all math teachers at the middle school level in Guilford County were history teachers. And so this meeting was intended to figure out how to make them better math teachers. Well, being the economist that I am, I sat there and I thought, well, there's a reason why middle school math teachers aren't good math teachers. They're credentialed in history. And then I thought, well, why are they bad math teachers? Well, if you think about the average history major, they chose history probably because they couldn't do math, or they didn't like math. Just like somebody picks math to major in math because they like math and probably don't like history. So I thought that the $3 million grant was probably not a very good use of money. So while this meeting was going on, I sat there quietly and scribbled this model that you see on like a napkin or something equivalent to it. Now, according to this model, in the mathematics market, if the school district listened to the private market or the free market, the school district had to pay math teachers $60,000 per year. Now, why do I say that? Well, that's what people with math skills can earn in the private sector for private firms. Profit maximizing private firms. If you're an econ major, the average offer that you'll get from a firm is in the $55,000 to $60,000 range. If you're an engineer, it's in the $60,000 range. Same thing for finance and accounting, $50,000 to $60,000 probably. Now, if you're a history major, you have probably majored in history. Not all history majors. This is not true for all history majors. You probably majored in history because you don't like doing math. Well, if you majored in history because you don't like doing math, and the only place that you want to work is in the private sector after you graduate, i.e. you don't want to work for a public school teaching history, well, there's just not a lot of opportunity out there. And that's why this wage is so low that I show you on this slide. There really isn't a lot of opportunity outside of the public school system. I mean, you can work for a museum, but you're going to start off probably being a tour guide. So if you do not want to work for a school district, or you can't find work with a school district, you might have to work at Starbucks as a barista for a few years until you decide, I've had enough of serving mochas. Unfortunately, that's the reality. And I'm not trying to besmirch history majors. I love history. But the reason why I chose economics is, one, I could do math, and two, I can make a lot more money doing it. Okay, so the school district says we're not going to listen to the free market because it's unfair to pay these people who are just teaching our youth. They're teaching, they're all doing similar work. We're going to pay all teachers the same wage, and that sounds great and all, but what does an economist do? Well, the economist doesn't intend to offend. The economist, I think, offends because an economist dares to suggest there are unintended consequences of such policies. What are the unintended consequences of paying every new math teacher the same salary of $30,000 a year? Well, according to this diagram, 30 history majors will be hired by the school district. You got a lot of people, a lot of history majors applying to the school district because they can make more money, $30,000 a year, than they would in the private sector of only $20,000. So you have 30 people wanting the 15 history slots. That makes the history department in a school probably much better, because you're not going to give these new positions or your openings, these 15 openings, to the weakest candidate. You're going to get to the strongest candidate, the candidate with the best teaching skills, the highest GPA is going to be hired. So you're able to cream out the top. You're able to take the cream of the crop right out the top because you're paying above market wages. So the least able history teachers are only going to make $20,000, you know, being a barista or a museum guide. Meanwhile, over in the mathematics market, nobody with mathematics skills is going to take the school up on its offer. Why is that? Well, they're only paying $30,000 a year for skill sets that are worth $60,000 in the private sector to a private company where that mathematician is doing statistics, economic analysis, accounting, finance, or engineering some bridge. So why would a rational being give up the opportunity of making $60,000 a year to make a measly $30,000? So Guilford County Schools ended up with 0 math teachers, or 0 people with math skills teaching math classes in the middle schools. So what is it going to do? It's going to take its surplus of history teachers, and it's going to make that surplus of history teachers teach the 15 math classes. And that is the consequence of not listening to the free market and paying everybody the same fair wage. It has consequences. I'm not saying paying the fair wage is a good thing. I'm not saying not paying that fair wage is a good thing. All I'm saying is there are consequences. If you want history teachers to teach math classes, you follow this policy. If, however, you want somebody that likes math, that enjoyed doing math in college, who has math skills, then you're not going to get them to teach in the middle school unless you pay them more. Now, I'm not saying pay them $60,000 a year, because working in a cutthroat industry, private industry, working 40, 80, 90 hours a week for some Wall Street bank, or doing economic analysis that means you come in on Saturdays and Sundays and you're doing this 12 months a year for the $60,000 is much different than teaching math in a high school. When you're teaching math in a high school, you get to go to football games, you get to interact with young people that want to learn. You typically have maybe a 3-day weekend, at least once a month. You have Thanksgiving off. You have maybe 3 weeks off for Christmas. You have a week off for spring break. You have the summers off unless you're getting a master's degree. So I'm not saying pay math teachers $60,000. What I am saying is maybe pay them $40,000. Just enough to draw some away from the private market, from the private sector. Now, the funny thing is, about a year and a half after this meeting took place on our campus, the school district over in Winston-Salem announced that they were going to do just what I was drawing or proposing to myself in this meeting. I didn't propose it to the body of the meeting because the purpose of the meeting was not to discuss a solution. The purpose of the meeting was how are we going to get this grant. So they had already made up their mind to get the grant, $3 million grant from the NIH. Now, another interesting question that labor economists answer often that gets raised by the media quite a bit, an issue that gets raised by the media quite a bit. How does an increased minimum wage affect workers and firms? Well, first and foremost, politicians generally propose an increase in the minimum wage to help the poor. Because maybe down here in this free market, firms and workers have decided or agreed upon 300 workers making $5 an hour. That's the free market. The free market says $5 an hour, and if that wage is paid by the firms, 300 people will do it. Let me ask you a question. Does the firm point a gun at the 300 workers' heads and says to them, you have to work or I'm going to shoot you? No. The workers choose to work for the firms at this wage. Maybe these workers are young people who want to make a better life for themselves, so they're working their way through college, right? So to assume that these same people are going to be working in this firm in 20 years from now is inaccurate. Many of these kids or workers that are making $5 an hour, they might end up being the CEO of the company, or they might end up being a CEO of a different company, or they may end up being an economics professor at North Carolina A&T. Now, in the free market scenario depicted here, again, there are 300 workers all making $5 an hour. If we multiply $5 an hour times 300 employees, we get $1,500 per hour. So the poor people in this labor market are making a total of $1,500 per hour. Now and that's the lower shaded rectangular box. This right here is the total wage bill of the firm. And a total wage bill of a firm is the total combined earnings of workers in the labor market. Now, if the intercept of the demand curve is 12, then the way we think about that is a firm would be willing to pay up to $12 an hour for that very first worker. But they only have to pay 5. So the difference between 12 and 5 is surplus that accrues to the firm. We call that firm surplus. They'd be willing to pay 12, but they're going, man, I only have to pay 5. That's cool. Now, what about the 50th worker? Maybe the 50th worker, the firm would be willing to pay $11 an hour. And they would be willing to pay 11 because that labor is so scarce, but they only have to pay 5. So that's $6 in surplus to the firm. Now, what about the 250th worker? Maybe the 250th worker, the firms would be willing to pay $6 an hour for that 250th worker, but they only have to pay 5. Now, at the market wage, that is the most they're willing to pay the 300th worker. So if you really think about it, at the margin, the last worker sets the wage. So you can think of the upper triangle as total or firm surplus. The upper triangle is firm surplus. Okay. Now, how does imposing minimum wage affect firm surplus and the total pay that poor workers or low-skilled workers are being paid per hour? Well, when the minimum wage is imposed, say at $8 an hour, well, it creates unemployment. Why do I say it creates unemployment? Because at the lower wage, everybody that wanted to work could work at that low wage. At this higher artificial wage, the number of people that wanted to work in this labor market went from 300 to 350. So 50 people are now looking for work in this labor market because the wage is $8 an hour. It's higher than it was at 5. So you can think of it that as those 50 being made worse off by this policy. They want to make $8 an hour, but they can't find work in this labor market. Now, firms, so more employees, more workers want to work at the higher wage. What are firms going to do? Well, firms aren't going to just say, all right, I'll continue with my 300 employees at that higher wage. Well, that's just not going to happen. When labor costs go up, firms look for ways to cut cost. And you see this when you go to the grocery store. If you've ever seen a self-checkout lane, the reason why there's a self-checkout lane there is because labor costs too much. You see it at grocery stores, you see it at Home Depot, you see it at Lowe's. You see it at McDonald's. Why do you think you're allowed to serve yourself in terms of soda pop or iced tea? You're not allowed to serve yourself coffee or a mocha, but you're allowed to serve yourself, you're allowed to get as many refills as you want. Why is that? Because McDonald's is trying to cut labor cost. Why do they have a drive-up window? Trying to cut labor cost. Less people in their store means they don't have to hire people to clean the store, or as many people to clean the store. Why do they put trash cans on your way out right next to the doors? So you bus your own tables. They can have fewer workers. If they have more people going through the drive-up lane, they got fewer people dirtying the bathrooms. So firms are not going to just sit there and go, we'll pay the $8 an hour and we'll continue to have 300 employees. Okay, so in this example here, the firm drops its labor force, maybe through natural attrition, like natural turnover. People leave the job for whatever reason. So you have this turnover going on. So through natural turnover, they're not going to. I don't think they would just fire everybody. They just won't hire to replace people that leave the job. So it goes from 300 down to 150. Okay, so now, what are poor people being paid in total? Well, you have $8 an hour, but you only have 150 people working at $8 an hour. So the total amount of money that poor people are getting is $1,200. That's a decrease of 20%. So you made poor people, in a way, 20% worse off. Now, what about firms? Well, firm surplus went from, what was it, 7 times 300 divided by 2. It went from 1050 down to what? 12 minus 8 is 4. 4 times 150 divided by 2. Firm surplus shrank from 1050 down to 300. So firms are worse off. They have less surplus. And poor people in aggregate are made worse off by this policy. In addition to that, you have unemployment. And when people are looking for work and they lost a job and they can't find work, they're probably going to end up collecting unemployment benefits. So, and on top of that, you have unemployed workers collecting unemployment benefits, and if they're unemployed, they're not paying income taxes. They're not paying payroll taxes. They're not paying the Medicare, the Social Security taxes. Is there a cost to immigration? Here's another hot button topic that politicians bring up a lot. In the low-skilled labor market depicted below, we have a wage of $10 an hour, and we have 1,000 employees, 1,000 low-skilled workers in this labor market working at $10 an hour. If we compute the firm surplus, which is 19 minus 10, or 9, times 1,000, divided by 2, we get $4,500 per hour in firm surplus. Well, how much are low-skilled workers making? Well, low-skilled workers are making in total per hour $10,000. Now, let me ask you a question. What happens when we open up the southern border with Mexico and we have a bunch of workers pouring in from Mexico? A flow of low-skilled workers comes into an economy and it does what to the labor supply curve. Remember, labor supply models worker behavior. So if there's more workers in an economy, then that means what? then the labor supply curve moves to the right. Now, this little triangle here, and this rectangle here represents the increase in firm surplus. Now, why is that? Before the immigration, firms were willing to pay the first worker $19 an hour and had to pay $10. After the immigration, the firm is still willing to pay that first worker $19 an hour, but now only has to pay $8 an hour. The next question is, how does this policy or flood of immigrants into an economy affect the native workers? Well, before the immigration, there were 1,000 native workers making $10 an hour. So this box right here, from 10 to 8 over 1,000, is the decrease in total money being paid to the native workers. What about the new workers? Well, the new workers, there's 300 new workers in this economy, and they were dirt poor in a different country, making, what it probably amounts to about as nothing in American dollars. They went from making nothing to making $8 an hour. The total amount of money being paid to low skilled workers it went from 10 times 1,000 or $10,000 to 8 times 1,300, which is 10,400. So the class of poor people are being paid in total more money. Now, this is just a short run look at the model. We've only gone one step. We've only looked at what happens immediately following a flood of low-skilled workers in an economy. Well, let's take a longer run, or a medium run look at the effects of this policy. Well, we know that the wage went from 10 to 8. Lower wages means firms' costs are lower. The marginal cost of production goes down. And when marginal cost of production goes down, that means output goes up, because a firm's marginal cost curve is its supply curve. So if a marginal cost curve falls, that means supply for that firm is going up. So if that's going on for many firms, or most firms, or all firms, then industry supply curves are increasing. And if industry supply curves are increasing, that means the aggregate supply curve is increasing. Okay? Now, firms don't just hire low-skilled laborers, right? If their supply curves are going up, they're producing more output. In order to produce more output, they have to do what? They have to hire more high-skilled workers, more medium-skilled workers, and more low-skilled workers. So if we reset this graph and we get rid of the word low-skilled here and replace it with high-skill and medium-skill, what's going to happen is when this immigration occurs, not only is the labor supply curve of low-skilled workers going to move to the right, well, labor demand for high-skilled workers moves to the right. So if this is, say, $40 an hour for medium to high-skilled work, then the labor demand curve is going to shift out here when there's a flood of immigrants from another country. That's going to drive up. So at the same time, low-skilled labor wage is falling from 10 to 8, high-skilled and medium-skilled wages are rising. In addition to that, think about this. Remember when we said when the wage falls, marginal cost falls, which increases supply, which increases industry supply, which increases aggregate supply. When that happens, firms are producing more. If they're producing more, they need more low-skilled laborers. So the labor demand curve in this model is not fixed. Most politicians assume it is. When the supply curves increase or the marginal cost curves fall, they're going to produce more. They're going to want more laborers in general. So the labor demand curve is also going to shift out. How much it shifts kind of depends on kind of depends on how long a run we're talking about. Are we talking about next year? Are we talking about 2 weeks from now? Are we talking about 10 years from now? The longer the time horizon, more likely the more the shift. So if we're talking about next month, the labor demand shift is probably going to be very small. Either way, the predicted wage that politicians throw out there really isn't the wage that is going to prevail. It's the lowest it can go if firms don't increase production. But if firms increase production, the wages won't fall to 8, they'll fall maybe to 9. Maybe they'll fall to 9.5. But it could be the case that they could rise to 10.5, depending on how big the output effect is. And we're going to get more. We're going to delve into that more deeply and more broadly when we talk about immigration in more depth in the future. Now, we're going to use data to confirm this theory. In Figure 2, this is from George Borjas, May 2004, increase in supply of labor through immigration. In the graph below, we have the change in immigrant share on the bottom. So, for example, this right here might be what? Well, that might be maybe a state like California. California went from 10% immigrants to 10.4%. That difference is 0.04. Down here, a state like, I don't know, Tennessee might have went from 5% immigration to 4.4% immigration. So this is a decline in the share of a state's population that is an immigrant. Up here we have the change in the log wage. Now we're going to learn that a change in a log wage is kind of like a percent change. So above zero here, wages are growing. Below zero, wages are falling. Now when we insert a trend line into the scatter plot, what do we get? Or we call this a regression line too. We get a negative relationship between what? The change in immigrant share and the growth in wages. So, for example, at this point here, the share of immigrants in a state is falling. Now, what does that mean in the previous slide? Well, that would mean the labor supply curve in the low-skilled labor market shifts to the left. Labor supply decreases. Now, if we hold demand constant, what happens to the wage in the very short run? The wage rises, right? So we'd have a percent change in the wage that is positive. On the other end, say like in a state like California, you have an increase in immigrant population. So that would do what to the labor supply curve in the low-skilled labor market? Well, low-skilled labor market, labor supply is going to move to the right because it's increasing. That'll drive down the wage, which is why this point corresponds to a negative percent change in wages. Now we can estimate this slope using these 2 points, or we can estimate the slope using regression analysis, which I'm going to show you in the slides to come. The rise from the 2 red dots, from one red dot to the other red dot, the rise is 0.03. The run is negative 0.09. So we're going from this point down to that point. The rise, or sorry, we're going from this point up to that point. So the rise is positive and the run is negative because we're decreasing change in immigrant share. So Borjas, if you read this paper by Borjas, his beta is probably equal to negative 0.33 or something close to it. Now what does that beta mean? Well, if the change in immigrant share increases by 1 unit, then the change in log weekly wages will fall by 0.33. So what that's saying is, if the immigrant population in a state is growing, the wages in that state are falling, which is confirming the theory on the previous slide. Okay, in the previous slide we used a scatter plot of two variables to understand the relationship between those two variables, which was done to confirm the theory that higher immigration leads to lower wages. Well, we don't need to rely on scatterplots. Scatterplots by themselves introduce as a variable bias. Multiple regression allows us to account for more things that might affect some variable. The multiple regression equation and the multiple regression model are two different things. The model includes the error term, the thing in purple. The equation that describes how the mean value of y is related to the independent variable is called a multiple regression equation. So it's almost the same thing, but just a little different. Here we have a value of y, and here we have the expected value of that y. The equation that describes how the predicted value of y is related to the independent variables is called the estimated multiple regression equation. And notice the difference here. We have y hat instead of expected y. We have b0 instead of beta 0, b1 instead of beta 1, b2 instead of beta 2, and bx instead of beta x. Now, this is one way to think about it. You're never going to know the betas. You're never going to know the error terms. So you're not going to know this relationship. Now, like back when you learned business statistics, you were taught the concept of a sample mean versus the population mean, or the sample standard deviation versus the population standard deviation. The betas, the sigmas, and the mu's are things you'll never know. But you can collect data and estimate their values. And that's what we're going to do in what follows. Now, before we get to that, we first need to formulate a research question. Like, for example, how has welfare reform affected employment of low-income mothers? Issue 1. How should welfare reform be defined? Since we're talking about aspects of welfare reform that influence the decision to work, we include the following variables. Welfare payments allow the head of household to work less. The variable TANF Ben 3 is going to be the real value in 1983 dollars of welfare payments to a family of 3. We'll also denote it as X1. The Republican-led Congress passed welfare reform twice, both of which were vetoed by President Clinton. Clinton then signed it into law after Congress passed it a third time in 1996. All states put their TANF programs in place by the year 2000. So the variable 2000 is 1 if the year is 2000, 0 if it is 1994. So in the data I'm going to present or use, we're going to have 2 years, 1994 data and 2000 data. So this is kind of like an experiment where you have a before and after effect. And then in between the before and after, something happens. Like, for example, welfare is reformed, or you're given a baldness pill. Okay, continuing on. Now, families receive full sanctions if the head of household fails to adhere to a state's work requirement. This happens in some states, not all. So the variable full sanction, or X3, is going to be equal to 1 if the state adopted the policy. It's going to be 0 otherwise. Now this is ignoring something else. Some states have partial sanctions. Okay, now how should employment be defined? One might use the employment population ratio of low-income single mothers, which we're going to do. So EPR is our Y variable. our variable of interest that we want to predict, is the number of low-income single mothers that are employed, divided by the number of low-income single mothers living in a particular state. So it's a state-level aggregate. 2, we're going to use economic theory or intuition to determine what the true regression model might look like. We're going to use economic graphs to derive testable hypotheses. We have consumption on the left-hand side. Now, if there's no savings, which is probably the case for low-income single mothers, savings is 0, so consumption is the same as income. On the x-axis, we have leisure, or activities that, if leisure goes up, then maybe mothers are staying home and taking care of their kids. If leisure goes down, then maybe the mothers are working and they're putting their kids in daycare. So leisure, you could think of leisure as being amount of household production. So it's unpaid household labor. This line represents the budget line. Now we're going to get really deep. We're going to get really in depth in this in future chapters. So don't worry about it too much yet. I'm just showing you how theory is used to derive testable hypotheses. So this is the budget line. Here, if the single mother is not working at all and only engaged in household production, doing the dishes, washing the sheets, taking care of the kids, teaching them the alphabet and their numbers, then this household has no money because the mother is not in the labor market making money. This point also assumes that the mother is not getting any money from government. This point up here means the mother is working all the time and has no time to do anything in the house with respect to washing dishes or whatnot, or taking care of the kids, teaching them letters. And so she has to pay somebody to do that for her in daycare, which would cost a lot because she's working all the time. Now this curved line is an indifference curve. Anywhere on this curved line represents the same level of happiness. Now don't worry about it for now. You might have covered this in micro principles. If you've had intermediate micro, you know what this graph represents. But for now, just push the I believe button. Anyone on this curve represents the same level of happiness. We're going to learn that where the budget line is just tangent to this curve, the single mothers that we're modeling here, have maximized their utility given their budget constraint. And in doing so, choose 40 hours of leisure. They're making $400 a week, which must mean they're making $10 an hour because maybe this woman has 80 hours to devote toward leisure and 80 hours to devote toward actually participating in a labor market by working for somebody for pay. So at this point, the person's working 40 hours a week, in the household, leisure, and is making $400 in the labor market because her wage is $10 an hour. Now, if government says, we're going to give you a check for $300 to help you out because your job is so hard, you're single, you got kids, you're trying to spend time with your kids, you do your job all day long, that leaves very little time for your kids, so we're going to give you a check for $300 to help you out. So how does that affect this woman's decision to work? This check being a welfare check, for example. It could also be a food stamp check. But we'll just assume that it is not, no matter what, it's $300, no matter how many hours the person works, it's just $300. So the check is not reduced as the person makes more and more income. It's just a transfer to this woman. Okay, so just giving the woman $300 shifts the budget constraint, her budget constraint, up everywhere $300. Now she has an indifference curve that is tangent to that line. So given the $300 check, what's this woman's new optimal solution? Well, now she's going to engage, she's going to work 55 hours doing household work, which means she can do 25 hours of work in the labor market working for some business. As a result, she's making 25 times 10, which is $250. She's making $250 in the labor market, and then government is giving her $300, so her income is $550. So the higher the check, the more money this person gets from government, the less this person is going to get work. Because instead of working for a firm, she's going to work in the household for no pay. So receiving the check means this person is going to work less. The person may also stop working altogether. Maybe their indifference curve passes through this point. Maybe this curve is very steep, and this one curve is very steep, and it passes through that point. In that case, the person would stop working altogether. So economic theory suggests the following is not true. Beta 1 here, it would be the coefficient of the variable x1, which is the amount of the welfare check. So x1 times beta 1 plus a bunch of other stuff equals the employment population ratio of a state. So beta 1 is the slope. Our theory says that beta 1 is not going to be 0. So we would reject this hypothesis if our theory is true. We can also use a mathematical model to derive testable hypotheses. So given this utility function, the square root of consumption times leisure. Now notice, as consumption goes up, leisure goes up, but it doesn't go up linearly. It goes up at a decreasing rate. The same thing is true for leisure. As your leisure goes up, your utility goes up, but it increases at a decreasing rate. And the reason why these two things are the case, because think about this, when you first take that bite of pizza, oh man, it feels so good. So you have this huge increase in utility, in satisfaction. But then, you take your second bite of pizza and it's, it's still great, but it's not as great as that first bite. When you eat your 50th bite of pizza, you're like, yeah, I don't want any more. Having an additional bite of pizza when you've had your 50th bite really doesn't make you any more happy. So your happiness increases at a decreasing rate. Same thing with leisure and consumption in general. Now you have these two budget constraints. Hours worked plus leisure is 80 hours a week. Remember, leisure is household production. H is working in the labor market for some private firm for pay. C is consumption. P is the payment given to you by government, the welfare check. W is your wage, and then H is your hours worked. Well, when you form a Lagrangian and you solve that Lagrangian function, the solution, after you do calculus, optimal level of leisure is equal to the welfare payment divided by 2 times the wage plus 40. So if the payment is 0, this person chooses 40 hours of work, just like in the previous slide. When the payment is 0, this person leisures for 40 hours a week. Therefore, when the payment is 0, the person works 40 hours a week. Now, if I differentiate this with respect to the payment, with wage being positive, what this says is if the payment goes up, leisure goes up. So this means what? If you're leisuring, you're not working. So the payment goes up, hours worked goes down. So this theory, this mathematical model, is saying more than just the hypothesis that beta 1 equals 0 is incorrect. It's saying that beta 1 is actually negative. Because remember, beta 1 is the slope coefficient that is multiplied by x1, and x1 is the value of the payment. So economic theory suggests the following is not true. Actually, it goes further. Like I said, it suggests that beta is negative. So it's not zero and it's not positive. So the next thing we do is after we collected our data, we compute means, standard deviations, minimums, and maximums for the variables. Our data set has the state, it has the year, it has the employment population ratio, it has a TANF benefit for a family of 3, it has whether the state sanctions or doesn't sanction. Now notice in 1994, Alabama, Alaska, Arizona, Arkansas did not sanction heads of households who did not work. The payments, the TANF payments seem low, but remember they're $1983. Alabama's payment to a family of 3 was only $110.06, whereas Alaska's payment was a lot higher. Now fast forward into the year 2000, Wisconsin, West Virginia, and Wyoming all have full sanction policies. Now because I have two time periods here, 1994 and the year 2000, there's 100 observations in this data. Now we want to control for things like maybe share of the population that is black, share of the share of the population that's a high school dropout, and maybe the unemployment rate in the state. The first two things are normal in such studies. They proxy for maybe the black share of the population, might proxy for cultural or urban effects. The dropout rate controls for education in the state, and then the unemployment rate is economic control. You have to control for the economy, because maybe women are working less because the unemployment rate dropped a lot. I mean, in Arkansas, the unemployment rate was 7.5, Alaska 7.5, and then you look at West Virginia, Wisconsin, and Wyoming, the unemployment rates are a lot lower. So maybe that has something to do with it. So here are the means of our data. Remember, there are 100 observations, 50 in 1994 and 2000 or 50 in 2000. So we added up the employment population ratios for all 50 states in 1994 and divided that sum by 50 to get this mean. We divided this sum by 50 to get that mean, yada yada yada. So what this says is in 1984, the average employment population ratio of low-income single mothers was about 47%. In 2000, it rose to almost 54%. So remember, the difference between 1994 and 2000 was welfare reform. Government wanted to change the incentive structures of welfare. And part of that was increasing work effort, reducing dependency. So maybe welfare reform in general is increasing the employment of women, disadvantaged women. But at the same time, you see a drop in the average payment made to welfare recipients. And remember our theory. Our theory says when this falls, and it does, women will work more. So maybe that has something to do with it. On top of that, look at this. 2% of states in 1994, one state, right? You have 50 states, 2%. 2 divided by 100 is 1 over 50. So there was one state in 1994 that had a full sanction policy. 70% of the states didn't have a full sanction policy in the year 2000. So that variable increased dramatically. The share of the black population fell just a little bit. The dropout rate dropped a lot. So what is that saying? Well, if the dropout rate is lower in a state, then it's probably lower for women. So the dropout rate is lower, then more women have at least a high school diploma, which should help them find work. So maybe that's explaining the employment population rate. Then you have a huge drop in the unemployment rate from 5.57 to 3.88. This over here represents differences. So the employment population ratio rose 7 percentage points. The TANF benefit fell $31.50 per month. 68%, there was a 68 percentage point increase in the number of states giving households full sanctions for failure of their heads to work. There is a 0.13 percentage point drop in the share of black households, share of state residents that were black. There was a 3.78 percentage point drop in the high school dropout rate, and there's a 1.69 percentage point drop in the unemployment rate. The next thing you want to do is scatter plot your Y variable, employment population ratio, versus your X variables, TANF benefit, dropout rate, black, and unemployment rate. Now this scatter plot shows what? It kind of is counterintuitive, isn't it? It's saying as the TANF benefit goes up, employment population ratios go down in the year 1994, but in the year 2000, we get a different relationship. As TANF benefit goes up in the year 2000, the employment population ratio is going up. Kind of odd, right? Remember, our theory said what? As the TANF benefit goes up, employment should go down. But you got to remember the difference between 2000 and 1994 is what? The difference is now women are required to work in most states. Welfare reform is very complex, and policy across states is really varied. Now, what about the dropout rate, or the share of the black population? As a state becomes more and more black, maybe more and more urban, maybe this variable is capturing the effect of urbanization, employment goes down in both years, 1994 and the year 2000. These two lines look very parallel, so maybe what's causing the red line to shift up to the black line is the low unemployment rate. And then the dropout rate, the higher the dropout rate, obviously the lower the employment population ratio, because if you're a high school dropout, you're going to find it harder to find, you're going to find it more difficult to find work. In 2000, the relationship becomes more pronounced. The unemployment rate and the employment population ratio of women is downward sloping, as we expect, in both years. Now, it's kind of funny, in the year 2000, the relationship is not quite as negative. Maybe that has something to do with welfare policy, right? The next, we want to compute the correlations. Now, if the correlation between any two pair of independent variables, any x's, is greater than 0.7, we might have what we call a multicollinearity problem. It is not possible to determine the separate effects of any particular independent variable. So, kind of a difficult issue to get around. Most computer programs that do regression analysis, other than Excel, when there's a problem, a variable is just dropped. Some say avoid including independent variables that are highly correlated, but it is better to have a multicollinearity problem than a variable bias in many economists' minds. Now, the yellow represents the correlations between the x variables, the things on the left, versus the y variable. And notice, this is kind of weird. The correlation between the TANF benefit and the employment population ratio is almost zero. Which is kind of what we're finding in that very first scatter plot. The strongest correlation is between the employment population ratio and the unemployment rate, which makes sense because the unemployment rate is the number of people that are unemployed are mostly comprised of low-skilled workers, and low-income single mothers are probably low-skilled, so this makes sense. Now, the correlations in the white columns, they represent the correlations between the independent variables, the x1 and x2, x1 and x2, for example. And the correlations are all less than 0.7 in absolute value, right? The highest correlation is between full sanction and the unemployment rate. But since it's between 0.7, it doesn't present a problem. The highest correlation between black and the other independent variables is between the share of the population that is black and the TANF benefit. Now, why didn't we need to calculate the correlation between black and black? Well, that'd be 1, right? Why not list the correlation between black and full sanction? Well, we did. It's right here. So this number would just be that number. This number would just be 1, and this number would just be 1. So we don't need to list the ones along the diagonal. And we don't need to list the correlations below the diagonal. So when you see a correlation table, it usually looks like a triangle. Dropout and the correlation between the other independent variables. The highest is between TANF benefit and the dropout rate. And then we have the unemployment rate. So it doesn't look like we have a multicollinearity problem here. So let's proceed. Now, sometimes it's common to take the logs of variables that are in dollar values. Remember, our TANF payment was $110 in 1984 for the state of Alabama. If you take the log of that, the natural log of that, you get 4.71. Now you got to remember, things that are in dollar values like payments, rents, incomes, they're very heavily skewed. So taking the logs helps minimize that. Taking the logs historically was a way to account for what we call heteroscedasticity. So it's very common to take logs. It also makes it easier to interpret the coefficients. The coefficient ends up kind of being like an elasticity. So this is very common. Logging Alaska's payment in 1994 gives you 6.43. Take the natural log of Arizona's in 1994 gives you 5.46, yada, yada, yada. So variable transformations of this sort are very common in economics. Now, the least squares criterion you learned in advanced stats, in your business stats, that expose you to regression. Least squares criterion does what? It minimizes the error. E is estimated error. Remember, we don't know the true area epsilon. Remember that? We don't know the true error epsilon. Epsilon, beta, mu's, and sigmas are all not going to be known to us, but we can estimate them. So E represents estimated error, or the residual. And that's just what we observe in the data minus what we predicted. Okay? And we want to minimize the sum of squared errors. We want to minimize the sum of squared error. Now, if we didn't square the errors, this sum would be 0. Because for every over prediction, there's an under prediction, and they wipe each other out. So that's what we square. So it's called ordinary least squares. Square what? Estimated errors. Okay. In simple regression, you can take the sample mean of your y variable and the sample mean of your x variable, multiply your sample mean of your x variable by the estimated slope, which is just the covariance that exists between x1 and y, divided by the variance of x1. So the reason why I point this out is because the slopes and the intercept are just sample statistics, because they're functions of sample statistics. Another reason why I want to point this out is because if y is the employment population ratio and x1 is the dollar value of a TANF benefit, the units here are percent and dollars. The variance, not the standard deviation, the variance would be in dollars squared. Now, dollars divided by dollars squared would leave dollars in the denominator because of canceling. So the slope would be percentage points divided by dollars. which is exactly what we expect in a regression line, right? Remember the scatter plot, the employment population ratio versus the dollar value of benefits. That scatter plot was downward sloping in 1994, right? And that slope is the rise over run. Well, the rise is the change in percentage points for the employment population ratio. The run is the change in dollars. So it really makes sense that this is the case. It's actually kind of elegant, kind of beautiful in a way. Now when we take the mean of y, remember, is in percentage points. The mean of x is in dollars. And we multiply dollars by percentage points per dollar, we get percentage points. So we got percentage points minus percentage points. So beta 0 is kind of a conditional mean. If the dollar value in a state said we're not going to have welfare, which would mean its payment to a family of 3 would be 0. 0 times this would be 0. 0 minus y bar would be y bar. So in states that have a 0 payment to welfare, low-income single mothers, because they don't have a welfare program, you'd expect the average employment population ratio in that state. Now in multiple regression, we use matrix algebra. This is a matrix of, if we have 6 variables, this would be a matrix of 7 columns, with the first column being a column of 1s. And then the next 6 columns would be the variables. So this would be a 7 by 100 matrix. But then we've got to transpose it. We take that matrix, transpose it, and multiply by itself. And then we take the inverse of the resulting matrix, and we multiply that by the transpose of our matrix of independent variables and a constant, and multiply that by the employment population ratio. Well, doing all that gives us the coefficients of the equation, namely B0, B1 to B6. Now the reason why I point this out is because if we have a multicollinearity problem and 2 of the x's are highly correlated, a lot of statistical, Excel, for example, can't compute this inverse, which is why programs like Stata, eViews, etc., drop a variable that's causing a multicollinearity problem. So we're not going to worry about the matrix algebra. I just pointed out to illustrate to you why Excel might crash if 2 variables are highly correlated. We're going to use Excel to compute the coefficients.